Hello, my name is James, and today we'll be looking at trig. Specifically, we'll be looking at how to find sine, cosine, and tangent of angles that lie on the coordinate axes, specifically 0 degrees, 90, 180, and 270. Before we do that, let us review how we do trig in general. So for this example, we'll be taking the sine of 30 degrees. The first thing we do is draw a line at our angle of interest. So here we have a line at 30 degrees. Second, we make a triangle by connecting the tip of our line to the x-axis. It is always the x-axis. Third, we label our sides. In this case, this is a 30, 60, 90 triangle, so the sides are labeled as such. Fourth, we use SOHCAHTOA to find the sine, cosine, or tangent, whatever we need, of the angle we're given. So for sine, it was the SO part of the SOHCAHTOA, so we do opposite over hypotenuse. In this case, the opposite of 30 degrees is 1, and the hypotenuse is 2. So the sine is 1 over 2, or 1/2. Sine of 30 degrees is 1/2. So now let's summarize this. We draw the line, we can make a triangle by connecting the tip of our line to the x-axis, we label our sides, and then use SOHCAHTOA to find our trig identity. So now how do we find the sine, cosine, or tangent of angles that are on the coordinate axes? We will use the same 4 steps that we did previously. For this example, we will use the cosine of 0 and cosine of 270. So let's look at cosine of 0 first. First, we'll draw our line. Now this is a little difficult to do because our line will lie exactly on the positive x-axis. But we'll draw our line a little bit above the x-axis so that we can actually see it. But in reality, this line is exactly on the x-axis. Next, we will make our triangle by connecting the tip of our line to the x-axis. Now, because the tip of this line is exactly on the x-axis, there's a 0 distance between the tip of it and the x-axis. This will be part of our labeling of sides. Now, when dealing with these angles, we can think that this line is in the unit circle. So our hypotenuse is 1. Now, because this line is in reality laying on the x-axis, its length is equal to that of the adjacent side. So both of these sides will always be equal. Now we use SOHCAHTOA to find our trig identity. So the cosine of 0, in this case, the angle here is 0, will be the adjacent side 1 over the hypotenuse, also 1. So the cosine of 0 is 1. Let's move on to cosine of 270. So we repeat the same steps. We draw a line at 270 degrees, a little bit away from the straight down coordinate axis, but in reality this line is exactly on the vertical line. We make our triangle by connecting it to the x-axis. Remember, it's always to the x-axis. We'll now label our sides. Remember, this line is lying exactly on the vertical axis, so this distance is 0. Now we use SOHCAHTOA, and we find that the cosine of 270 is the adjacent side, which is 0 in this case, over the hypotenuse, which is 1. The diagonal line is 1. 0 over 1 is 0, so the cosine of 270 is 0. Now, you can read this, or just pause the video and read this if you like, but this slide can better be summarized in this picture. We always want to relate y to the y-axis to sine, and the cosine to the x-axis. Where x is positive, cosine of an angle is positive there. Where cosine is negative, that means the x-axis was negative there. So where the y-axis is positive, so sine is positive, and same thing for the negative y-axis and negative sine. When we take a cosine or sine of an angle, the cosine of an angle on the x-axis, it'll be positive where x is positive and negative where x is negative. Same thing with the y-axis. When we take the sine of something that is on 90 degrees, for example, it'll be it'll be a positive sine. But the trig identity for something in the negative y will be negative. So for example, the sine of 270. Here we have our triangle for 270 degrees. Now, sine is opposite of hypotenuse, so opposite 1, hypotenuse 1. So our answer would be 1, but because sine is negative in the negative y-axis, the sine of 270 is actually negative 1. So here's a summary of what we've talked in pictorial form. Remember, just draw your triangle, label the appropriate sides. One side will always be 0. And then look at where is sine positive or negative, where is cosine positive or negative. And that way you can take the sine, cosine, or tangent of angles that lie on the coordinate axes.